In the early 17th century, a religious man decided that he was going to uncover the architecture of the universe itself, using observations of the heavens and a deep understanding of geometry. This man conjectured a world of harmonious design where the secrets of God's creation could be deciphered by anyone willing to use mathematics to look for them. In the course of his quest, this man managed to change our understanding of astronomy forever. His name was Johannes Kepler, and he would go down as one of the greatest scientists to ever live. Johannes Kepler was born on December 27, 1571 at Wilderstadt, Württemberg, Germany. He is a well-known German astronomer, mathematician, and astrologer. He is famous for his laws of planetary motion. Kepler came to write about 26 books during his lifetime, which included astronomy and math. Kepler was alive during the late Middle Age and the early Renaissance. Kepler lived from the year 1571 to the year 1630. Born into a divided Europe, Kepler grew up during a time of unfathomable change. Yet Kepler managed to not just navigate through these changes, but to do so while transforming science. He discovered the laws of astronomy, changed our understanding of optics, pioneered crystallography, developed telescopes, and even wrote what's likely the first work of science fiction. Persecuted for his faith and misunderstood in his lifetime, this is the life of Johannes Kepler, the man who discovered the secrets of the universe. During the time of Johannes Kepler, it was into a Europe already reeling from two major revolutions. Half a century earlier, a man named Martin Luther had nailed his 95th thesis to a church door, kicking off a century and a half of a religious upheaval known as the Reformation. 26 years after that, in 1543, the astronomer Nicolaus Copernicus proved that the sun did not orbit the Earth, but the other way around, triggering an even bigger upheaval known as the Scientific Revolution. By the time Johannes Kepler first opened his eyes, these twin revelations were causing Europe to strain at the seams. Not that Kepler's parents could have imagined he'd live long enough to see those seams ripped wide open. And now, we will be talking about Johannes Kepler's laws of planetary motion. Kepler's first law. Each planet's orbit about the Sun is an ellipse. The Sun's center is always located at one focus of the orbital ellipse. The Sun is at one focus. The planet follows the ellipse in its orbit, meaning that the planet to the Sun's distance is constantly changing as the planet goes around its orbit. Kepler's second law. The imaginary line joining a planet and the Sun sweeps equal areas of space during equal time intervals as the planet orbits. Basically, that planets do not move with constant speed along their orbits. Rather, their speed varies so that the line joining the centers of the Sun and the planet sweeps out equal parts of an area in equal times. The point of nearest approach of the Sun and planet is termed perihelion. The point of greatest separation is aphelion. Hence, by Kepler's second law, a planet is moving fastest when it is at perihelion and slowest at aphelion. Kepler's third law. The squares of the orbital periods of the planets are directly proportional to the cubes of the semi-major axes of their orbits. Kepler's third law implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. Thus, we find that Mercury, the innermost planet, takes only 88 days to orbit the Sun. The Earth takes 365 days, while Saturn requires 10,759 days to do the same. though Kepler hadn't known about gravitation when he came up with his three laws. They were instrumental in Isaac Newton deriving his theory of universal gravitation, which explains the unknown force behind Kepler's third law. Kepler and his theories were crucial in the understanding of our solar system dynamics, and as a springboard to newer theories that more accurately approximate our planetary orbits. Now in conclusion, Kepler's law of planetary motion in astronomy and classical physics, laws describing the motions of the planets in the solar system, they were derived by the German astronomer Johannes Kepler. Kepler's contribution to the study of astronomy and planetary orbits reached well beyond the Renaissance period. His discoveries had an impact on other areas of science, including physics, optics, and crystallography. He was not as well known as Galileo or Newton, but his discoveries were equally important. Without Kepler's law of planetary motion, Isaac Newton may never have come to his conclusion about the law of gravity. Kepler's three laws of planetary motion can be stated as follows. All planets move about the Sun in elliptical orbits having the Sun as one of the foci. A radius vector joining a planet to the Sun sweeps out equal areas in equal lengths of time. The squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distances from the Sun. Again, those are the three laws of planetary motions by Johannes Kepler, the man who would go down as one of the greatest scientists to ever live.